Hello everybody, myself Jyoti and we are studying spectra of diatomic molecules. This is lecture 8 and today, so in the last lecture we studied about the vibration rotation spectrum and today we are going to talk about electronic spectra of diatomic molecules. Now, when do we get a spectra? We get a spectra when there is a transition which is taking place from one energy level to another energy level. When we talk about rotational spectra, the transition takes place between two rotational energy levels. When we talk about vibrational spectra, the transition takes place between two vibrational energy levels. Similarly, when we talk about electronic spectra, the transition takes place between two electronic energy levels. Now, electronic state, we have three molecular states. One is rotational state, vibrational state, and third one is electronic state. Rotational state, it is because of the rotation of molecule as a whole. Vibrational state, it is because of the vibration of the atoms about them in position. And electronic state of a molecule arise because of the electronic configuration of the electrons in the molecule. And we know that rotational energy state, it is of the order of milli electron volt. Vibrational energy state, it is of the order of zero point 0.1 electron volt. And when we talk about electronic energy state, these are of the order of few electron volts. That means the energy is highest in case of electronic spectrum. And the spectrum which we get because of the transition happening between two electronic energy levels, that spectrum, it lies in visible and ultraviolet region. In case of rotational spectra, the spectrum lies in the microwave region. For infrared spectrum, the spectrum lies in for vibrational spectra, the spectrum lies in the infrared region. So you have to remember that in which region we expect which spectra. Okay, now just like the vibration rotation spectrum, it is also called as vibration rotation band. Similarly, electronic band. So an electronic transition does not appear as a single line, but a series of closely spaced line, and that is why it is called as an electronic band. So when we talk about electronic energy level, where you see number of energy levels, why so many number of energy levels, in the last lecture we have seen that when we talked about vibration rotation spectrum, each vibrational state, it consists of number of rotational energy levels. So transition, in case of vibration rotation spectrum, transition takes place from one rotational level of a vibration ground vibrational state to another rotational level of another vibrational state. So each vibrational state, it will have number of rotational energy levels. Similarly, here when we talk about electronic energy level, for each electronic energy level you have number of vibrational energy levels, and for each vibrational level you have number of rotational energy levels. हर एक जो इलेक्ट्रॉनिक एनर्जी लेवल है दैट कंस्टिट्यूट ऑफ नंबर ऑफ वाइब्रेशनल एनर्जी लेवल्स, और हर एक जो वाइब्रेशनल एनर्जी लेवल है दैट कंस्टिट्यूट ऑफ नंबर ऑफ रोटेशनल एनर्जी लेवल्स. सो देर आर सो मेनी क्लोजली स्पेस्ड एनर्जी लेवल्स. दैट इज हाउ we call it as the electronic band. Now, when we studied rotational spectra or vibrational spectra, that time we said that all homonuclear molecules do not exhibit rotation spectra or vibration spectra, but homonuclear molecules, they do exhibit electronic spectra. Why they do not exhibit the rotational and vibrational spectra? Because according to classical electrodynamics, if we want vibrational spectra or rotational spectra, the molecule should have a changing dipole moment. In case of homonuclear diatomic molecules, there is no changing dipole moment, and that is how we do not get rotational spectra and vibrational spectra in case of homonuclear molecules. But when we talk about the electronic spectra, uh, we in for homonuclear molecules we get electronic spectra, or they exhibit electronic spectra, because the dipole moment always changes whenever the electronic configuration changes, and in case of electronic spectra there is a change in electronic configuration. Now, here also we are going to use Born-Oppenheimer approximation just the way we have used it in the case of vibration rotation spectrum. According to Born-Oppenheimer approximation, we can consider that all the motions, rotational motion, vibrational motion, and electronic motion, they are independent of each other. That is what the Born-Oppenheimer approximation is. There is no interaction energy term. So there is no effect of rotation on vibration. There is no effect of vibration on electronic or electronic on rotation that way. See, all three motions, we have three motions, uh, rotational motion, vibrational motion, and electronic motion. All these three motions, they are independent of each other. Hence, what we can write is total energy, it will be just the sum of these three energies. So we can write total energy, it is the sum of electronic energy plus vibrational energy and uh, rotational energy. Or in other words, we can write change in total energy, it is equals to change in electronic energy plus change in vibrational energy and change in rotational energy. Now, electronic energy changes about 1000 times as compared to change in vibrational energy, and vibrational energy changes about 1000 times change in rotational energy. So when we talk about vibrational changes produce core structure, and rotational changes produce fine structure of the spectral lines arising from electronic transition. So we will see what is core structure and fine structure. I'll explain that too. Now look at this diagram. I already told you. See, we have the red lines. They indicate the electronic energy levels. Just a second, huh? These red lines, they show electronic energy levels. So we have E0, E1, E2. These are the three electronic energy levels. And for corresponding to each electronic energy level, you have number of vibrational levels. ये suppose 1 nu equals to 0 है, ये nu equals to 1 है, ये nu equals to 2 है. Blue lines, they represent vibrational energy level. So हर एक electronic energy level के लिए we have number of vibrational levels, and corresponding to each vibrational level we have number of rotational energy levels. हर एक इलेक्ट्रॉनिक एनर्जी लेवल बहुत सारे वाइब्रेशनल लेवल से बना है और हर एक वाइब्रेशनल लेवल बहुत सारे रोटेशनल लेवल से बना है. So these green lines, they represent the rotational energy levels. That is how these energy levels are very closely spaced, and that is why we call it as an electronic band. Now what is core structure and fine structure? See, if you are using a spectrometer with a less resolving power, then in that case you will be able to see these vibrational energy levels only. You won't be able to see rotational energy levels. That is called as core structure. When you can see only lines corresponding to vibrational energy levels, that is called as core structure. But suppose if you use a spectrometer with a very good resolving power, very high resolving power, then in that case you will be able to see this rotational energy levels as well. So in that case we call it as a fine structure. सो लास्ट टाइम हम लोगों ने देखा था हाउ द वी हैड वन वाइब्रेशनल एनर्जी लेवल करस्पॉन्डिंग टू वाइब्रेशनल एनर्जी लेवल वी हैड नंबर ऑफ वी हैड वन vibrational energy level corresponding to vibrational energy level we had number of rotational energy levels, and in case of vibration rotation spectrum, transition was taking place from one rotational level of ground vibrational state to another rotational level of excited vibrational state. In case of electronic transition किसके बीच में होता है? See, whenever you study spectroscopy, you have to understand the very first point, that between which two energy levels the transition is taking place. In case of electronic transition takes place between vibrational state of one electronic state to vibrational energy state of another electronic state. ये एक electronic state है, ये second electronic state है. This is E1, this is E2. ये E1 के अंदर we have number of inside this E1 we have a number of vibrational energy levels. corresponding to this energy level E2 we have number of vibrational energy levels. और ट्रांजिशन किसके बीच में हो रहा है? बिटवीन वन वाइब्रेशनल स्टेट ऑफ वन इलेक्ट्रॉनिक स्टेट टू vibrational state of another electronic state. So suppose transition is taking place from 0 nu equals to 0 ground vibrational state of ground electronic state to ground vibrational state of excited electronic state, then this is 0 0 transition. ठीक है. Then if a transition is taking place from ground vibrational state of ground electronic state to first nu equals to 1 of another electronic state, that transition is written as 1 0. How do we write? Upper excited state vibrational number we write upper excited state vibrational number and lower excited state vibrational number. यहाँ पे transition कौन सा है? 0 0, then ये 1 और 0, 2 और 0, 3 or 0, this is 4 and 0, this is 5 and 0, this is 6 and 0. That is how the lines are. So we had two energy levels, एक E dash था, एक E double dash था ऊपर, and corresponding to E dash we had number of energy levels, vibrational energy levels. Corresponding to E double dash we had number of energy, vibrational energy levels, and the transition was taking place from one vibrational state to another vibrational state of different electronic energy levels. So the transitions shown in figure, they constitute a band, and that is how it is called as vibrational band. And each line of vibrational band has a fine structure because each vibrational state consists of number of rotational state. So सिर्फ vibrational lines जो है that constitute core structure, लेकिन each vibrational state that consists of a number of rotational energy levels, so that has a fine structure. Now the lines of vibrational band are conventionally labeled according to their vibrational quantum number. अभी मैंने बताया कि upper state number हम लोग पहले लिखते हैं and then lower state number. So transition in the figure was labeled as 0 to 0, 1 to 0, 2 to 0, 3 to 0 and so on. And here you can see जो first number है that is the upper state number. So 0 से 1 हुआ, फिर 1 से 2 हुआ, फिर 2 से 3 होगा and so on. So vibrational band, it is also called as nu dash progression, because if you see here the vibrational quantum number, it is changing by 1 as we go from one line to another line. So it is called as nu dash progression. So that's all about electronic transition.